And live. Okay, it is Thursday, April 2nd, 2015, 11 a.m. Pacific, and this is DB Hangops. Today we're going to be talking, we're actually going to have Mark Leith talking about performance schema, fielding questions, and just kind of showing, getting started with it and kind of things you can do with it. And I'm not sure how many people are using performance schema yet, but if you aren't, you totally should be. And if you're not on a version of MySQL that uses it, at like, let's just say 5, 6 or newer, you really should get there. You should try and get there because this is really cool stuff. And beyond that, just kind of open Q&A about other general things. One of the questions I had was like, what's the hardest problem you've debugged, and other things like that. So we'll kind of see where we go after the performance schema stuff. And let's do a quick round of introductions. So my name's Jeff Anderson. I'm a DBA at Box. Mark?
Hey, I'm Mark Leith. I'm a development manager with MySQL at Oracle.
And
Hi, I'm Shlomi. I'm an system engineer at Booking.com.
Okay, so yeah, without further ado, Mark, take it away. And do you want us to ask questions, or do you have something that you want to kind of go through?
I'm going to bring up a terminal, and I can go through the basics if you want me to. It would be nice if you want to ask questions, I can point you in the right direction. I'm trying to screen share at the moment, but clicking the button's not really doing anything.
Yeah, we can see the reflection in your glasses.
So I'm right. I clicked that screen share button, right? And
yep, and it should change your camera to whatever's on your screen. Hasn't done that yet. We still see you.
I don't know how many times I can click it, but it's not.
Well, when you click it, it should pop up a box to choose a window to screen share or the whole desktop.
Ah.
Maybe we should have done this before starting the recording.
It pops up in the background, which is awesome. But
there we go. Yeah, we've got your terminal now.
Okay. Is there any questions that you actually wanted to ask?
Well, so I guess so. Are you going to run on a 5.6 or a 5.7 to start?
I can do it on either, really. The load that I've got going is on my 5.7 instance. I can show you the defaults for things like a 5.6 instance as well. I'll start there, I guess.
Yeah, let's do a 5.6 because that's what we expect people to be using right now.
How do you guys see my screen? Does it look okay to you?
Yeah, it's pretty okay. If you could enlarge the fonts a little bit, it would be great. Otherwise,
is that any better? Or?
Yeah, that seems good right there.
Yeah.
Okay. So performance schema, just starting with the absolute basics. It's this new database that was in 5, in fact. It's a database. It's also a storage engine. So all of the tables that you see in performance schema all use this performance schema storage engine. And it's a set of interfaces in the server itself that allow developers to add instrumentation points in the server. So most of the tables themselves are a way to expose all of those instrumentation points. And then there's a number of tables, these setup tables, which are there to actually set up how the instrumentation is recorded as well. So the most basic one to understand is this setup instruments table, which basically defines what is turned on and off in terms of instrumentation points in the server. So I mean, you can see the list is massive. In 5.6, one of the things that we did to limit the overhead of performance schema itself, because if you tried it out in 5.5, and I know a lot of people are still using 5.5, but if you try it out in 5.5, we turn on things like mutexes, or all of these mutexes, and read-write locks, and conditions, which are basically the internal synchronization points in the server that sync across the different threads that run within the same process. We turn on all of that by default in 5.5, and the overhead is quite high because those things get called a hell of a lot. And then we have file I/O as well. But in 5.6, what we've done is we've disabled all of this by default. So you see this is the enabled and the timed columns, so we turn those off by default. And we only turn on what we think are the interesting things by default in 5.6. And not only the interesting things, but things that take a while to actually do within the server as well. So if you look at something like file I/O, performing some file I/O takes a while, and actually recording the instrumentation around it is a very small percentage of that. Similarly, we turn off things like stages. Stages are the thread states that you see in something like a show process list, for example. So you see like creating temp table and the cleaning up and closing tables. You should be used to the names of those things from like a show process list and the thread states. Those aren't turned on by default. But then you get to statement instrumentation in 5.6 as well, where we do turn on all of those, and each of the instruments are the very specific types of statement as well. So you can turn on or off individual tracking of certain statements as well. If you don't want to record anything about show statements, for example, you could turn off instrumentation on all of the show commands if you wanted to. It's up to you how you want to track that stuff. The one thing to note between statement SQL and statement COM, SQL is an actual SQL statement, interacting with like a select or a delete or whatever it might be. And then COM is the actual protocol commands. So you can run like a COM ping, prepared statements on the protocol rather than an actual prepared statement itself, the SQL command. So we split those out, and we actually track those individually as well. And then we have network I/O as well, which we don't enable by default. And somewhere I think I've scrolled past it. We have table I/O and table locks. So these couple of ones as well, which we do turn on by default. So that's actual storage engine handler level I/O, so reading and writing rows, that kind of stuff. We do track all of that by default in 5.6 as well. So the 5.6 set of default instrumentation is fairly conservative. We track statements, we track file I/O, we track the table I/O as well, and we track table level locking. That's full table level locks, not row locks in ODB. But then we turn. Oh, go for it.
So you were saying the statement /SQL /instruments. Those actually track the text and body of queries that go through the server, versus the statement /com instruments, which just track counts of those. Is that correct?
It's not just counts of those things. We track a lot more with both of them. So we don't just track the counts. We track the latency for those things as well. And they even, a lot of these can actually return results and numbers of rows and those kind of things too. So we track what's appropriate based on the statement itself, essentially. So to give an idea, in 5.6, in 5.5 you'll see all of these tables, which are the weights, because we started with the lower level stuff, and then in 5.6 we eventually brought it back up to the DBA level. So in 5.6 we have the statements and we have these stages tables as well, and they both give you raw data. So when you look at the current or the history long, you're looking at raw data. And then when you look at any of the summaries, you're looking at summarized data over time, essentially. So raw data is the current and the very near-term history. and then the summaries of those things. So to see what you get on a statement, this is the kind of data that you get on a per statement basis. So you can see essentially who executed it, some event IDs which are used to track it, the type of thing, so whether it was a select, a delete, a com, ping, whatever it might have been. The timing information, so how long it took when it started and ended, in picoseconds. And then a whole bunch of statistics about the actual thing, right? So how long lock time took, the SQL text for the actual statement itself, a digest, which I'll get onto in a little bit, what schema it was on, whether it returned errors or not, and the message that it returned if so, whether it had any warnings, and then actually on the statement execution, if it's a DML, then how many rows it actually updated or deleted or inserted, how many rows it sent back to the client or examined, that's how many it scanned versus actually sent back in the result set. The temporary table statistics on a per statement basis. These are the show status type variables that you're used to. So when you see them on a global level or whatever it might be, this is on a per statement basis, whether it did a full join, arrange, how many sort merge passes it did, how many rows it actually sorted, and those kind of things. These were actually exposed in the protocol itself, but never exposed anywhere else, which basically a couple of flags that say whether it used an index or not for the query to satisfy the query. The difference between no index used and no good index used is this is just it didn't use an index to satisfy some table access, and then no good index used means it didn't use an index to satisfy some join condition access, essentially. And then some nesting type info, so wait events can nest within stages, and stages can nest within statements, and you can end up creating this whole big graph of events if you want to as well to see exactly what a statement affected, what kind of weights it did underneath it from stages and weights and the like. So you can see the raw data for that with, I shouldn't have done that. With the current table, this shows you any statements that are currently executing, which at the moment on my dead box, this is a dead instance, is just my currently executing statement. So this statement here is the one that I'm executing. You can see it's doing a scan, not using an index because I'm selecting everything. This is live as well, so all of these statistics are live on the current. So if you have some currently executing statement, you can tell that it's currently executing with timer end being null, essentially. But then the rest of the statistics here would be live. So you'd see it created so many temporary tables, how many rows it had scanned with rows examined, for example. All of that's pretty much live on the current consumer. But then, see where I had getting back to the digest, and I'm gonna click to a different instance just to show some actually running stuff.
So that definitely seems pretty useful. Just like if you have a server that is, maybe a flood of statements keep coming in and you're not 100% sure what's causing them, you could use this to evaluate it. Because right now, just thinking about it, if I have a server that's in an unhealthy state, I either have to wait until the next time a slow query log collection automatically happens, or I have to consciously make a decision to turn it on for a couple seconds or minutes, turn it off, and then run ptquery digest to see if I can figure out what statement is kind of flooding in. So it seems like you could query this just on the spot and try to get some high-level counting.
Yeah, I mean, that's pretty much the idea. Everything is live, and with the PT query digest and those kind of things. So event statements current, it shows the currently executing or the last one. So these are the last statement that executed on a per thread basis as well. So across all the connected threads, the last one in mine, a lot of them have just last executed a commit in the transaction essentially. So nothing is currently executing, I guess. But then when you want to look at the digested set of data, there's this other table, and this is the 571, but sorry. There's this other table, this event statement summary by digest, which does that. So the digest is the normalized form of the statement. It strips out all of the literals, all of that kind of stuff, and gives you an aggregated set of data on a normalized statement basis, right? So you can. It's got the same set of columns on there essentially, but they're all aggregated together. So it's the sum of that rather than the time await essentially. And you can order by all of that pretty easily, so that you can, or do whatever kind of select you want. Not just order by the sum time await. You could order it by the total temporary tables if you're looking for temporary tables and those kind of things. Commit's my longest running one because commit causes an fsync, of course, under the covers. But then my second longest one is this insert statement, which is inserting into query analysis. So this running instance has got mem running on top of it, and obviously the heaviest data for us is our query data. So it proves it with the insert on that table. But that's the normalized form of the statement as well, right? So you can see that it's executed, almost 5,000 times. It's sum of its time information, the min time, the average time, the max time, and then all of the other things that you saw in the current. So how many rows it affected in this case because it's an insert statement. If I can find some more interesting ones. Selects, yeah, so this one you see, it's kind of interesting here. It's executed 6,000 times, but it's only scanned a couple of times. That might be some cardinality type issue or something. Updates, and there you see the actual normalized statement where the literals have been, taken out and replaced with the question marks. How many rows it examined to update that many rows? It didn't. It used an index for all of those, so it's fine, but it still takes the fourth most time out of those kind of things. So you don't have to post-process a log. You don't have to have the log file on, which is also a bottleneck as well, because writing to a file incurs a mutex lock and concurrency issues because no two threads can write to the same file at the same time. But all of this data is collected without those kind of mutex issues. It's all stored in memory, so it's easy to query. You can query it however you want to as well. So you can look for any one of these types of conditions depending on the use case that you're looking for. So that's the query data. It's really, really useful. I guess an example of it is you guys have heard of sys, and for those that haven't heard of sys, it's this schema that I've created, which basically it's a set of views and objects and alike that sit on top of performance schema, if you will. So each one of these views is looking at that statement data, right? So spell. You see the same kind of data. Commit is the top one. The selects are the next one. The updates are the whatever. But it actually formats it out nicely for you. So you can see it's easily that it's 16 seconds rather than some huge picosecond value. But then, based on the different use cases, like I said, statements with temporary tables, before you'd see on a graph tracking some status variable, for example, that just tracks created temp dist tables versus created temp tables, and then you'd have to try and figure out, okay, how do I then find out what statements are actually creating those temporary tables, right? You've got a simple counter and nothing that equates them to the actual tables themselves. Now instead you could query, go straight back up, you could query based on these couple of columns if you wanted to see the raw data, which is essentially what that view in the sys schema is doing. Screwed. Or you can just create, this one instead. Then it sorts by the total latency of the statements that create those temporary tables. And you can generate some stats on top of it as well, which is what this does. So this query executed 177 times. Every time it created a temporary table, both in memory and on disk, so it always converts it to a disk table 100% of the time. So you can get an instant picture of every single statement that is actually creating temporary tables, and actually those that create the most temporary tables and spend the most time doing those things as well, right? So it's a very quick and easy way to drill into those different use cases where before you just have a graph that says, okay, there's this big count of things that happened and you have to try and find what statement it was, and kind of hope that you had some logging enabled or something like that that can tell you that. Where with this in 5.6, it's enabled by default. There's nothing to enable at all. It comes like this, pre-configured. You can load something like sys and get this kind of data, very, very quickly. There's no magic to it. You just query the raw performance schema tables based on those kind of use cases. Right?
Yeah, we're actually using these performance schema tables for aggregating the slow queries, and we have this nice dashboard that shows us just what slow queries are running right now or in the past 10 minutes. So it's pretty handy and it's very nice. We don't see too much of an overhead for enabling performance schema, and the general conception is that it doesn't matter too much. The added value is just worth it.
Yeah, and a lot of the work there is, I mean, there has been a lot of work there in terms of overhead and all of that kind of stuff since 5.5. Enabling a subset of the things helped immensely, but also just a lot of work in making sure that the way the code executes is as performant as possible as well. And then it's been a long road, but 5.6 I think by default is really reasonable. I mean, in the benchmarks that we've done for the default instrumentation, it's always less than 5%. And to get the kind of data, not just this query data as well, right? I mean, there's all of the table instrumentation data as well. So these tables here in Performance Schema 2, the table IO weights, and they're weights by table and by index too. So if I see what that looks like, it's by the table name, then how many I/O weights there are. So each of the I/Os, by the count of each of those things, is by some row being read or written across the storage engine layer, essentially. And then we break it down by the type of I/O that happens, right? So whether it's a read, a write, a fetch, an insert, an update, or a delete, whatever it might be. So I'll give a quick example of it. You can see, again, like I was saying earlier, Quan is our heaviest table, not just by the insert. So you can see the inserts are very heavy, but really the inserts are heavy because the amount of time that they take is because of the amount of time that some of this is taken as well, right? They're actually inserting and alike across the storage engine layer with the big amount of data that they actually insert. So this shows not just at the statement level, but actually at the table level that these are our heaviest tables, essentially. And you can tell they're heavy and even maybe a little bit contended because it happens less often, but it's still the highest latency for all of that stuff. So that's a nice, quick, easy way to not just find out which are your heaviest tables as well, and this is on by default too in 5.6, but also why as well, because it's not just this count star and the sum, which is the high level picture of it. You can actually figure out if it's through reading or writing, which this is aggregated at the top level, then whether it's being read or written in some way, and that includes delete or update or insert. And then you can even get very, very detailed by looking at the insert, update, or delete statistics individually as well. So you can tell if the table is heavy just from delete access or from select access, whatever it might be. And again, sys has something that makes querying that very easy. So sys has these schema views too, so you can have a high-level schema statistics, or you can look for ones that have unused indexes, which are basically any index that has a count star of 0 against it means it hasn't been accessed in any way. So you can give an example of that. Use the right schema. But it's formatted again very nicely for you instead of seeing the large numbers of rows. The other thing with this view is it joins the table statistics. So that's what you were seeing in the table statistics. It attempts to join that with the file I/O statistics as well. So because these tables use InnoDB file per table, it's easy to find out by the file name, not just its table I/O, the storage engine, the logical I/O across the storage engine layer, but also its physical I/O as well, so that you can see a picture of not just how long rows are taking across the storage engine layer and why. In this case, you can see most of the time is in insert here. A very minimal time is in actually selecting or updating or whatever it might be. And then you can see the very specific file I/O stats as well, right? So we don't read from it very much, but because I'm not using the data in my test instance, but we're writing to it a whole bunch, right? So you can see the picture of both logical and physical I/O across all of the tables too. Again, all of this is enabled by default, so there's no magic, nothing to do there. It's just there. You can select from it. So that was Well, going back to 5.6. That's statement statistics. Weights are getting down into the very detailed things like the file I/O and all of that kind of stuff. You can see these file summaries as well. So this is the most the files that have the most latency against them. For instance, obviously my IP data is the number one, but then some FRM file is number two, which is kind of interesting and odd, right? Some database options files. Actually, it's not odd because this is a dead instance. Let's go back to a more interesting one. But again, IP data is my most contended, or not contended, has the most file I/O latency against it, whatever it might be. So then your redo logs, some temporary FRM file, a redo log again, some temporary FRM file, some data file, and you can see again the type or where the time is being spent for those things as well. So with file I/O, it's the count is the total time, total number of operations, and the total time spent. But then it breaks down by whether you're reading and how much you've read, whether you're writing and how much you've written. And the MISC is things like opening the file, f-syncing the file, you know, all of those things, file operations that don't involve reading or writing some number of bytes against it, closing the file. Generally, you'll find for things like InnoDB data files and things like the redo logs, for example, the big time will be spent in MISC. You know, this is actually f-syncing the file versus writing to some file system buffer, for example. But you can see that, you know, very easily and very quickly on a per file basis as well. So not just at the table I/O level or even at the statement level that I showed further up, but down right to the file I/O level and where all of the time is being spent in that file I/O.
This also sounds like it might be an interesting way to gauge, like, if you have a bad disk or something, and provided these files are spread across different mount points or something even. For example, if you have your data files on a different physical set of drives than your IB log files, and you see a massive increase in timer reads on, you know, the IB log file data from here, for instance, you could probably determine if you have a bad disk coming before your host even notifies you.
Maybe. I mean, if the latency is affected with the bad disk, you know, it could be, it couldn't be. Who knows? But I mean, if latency is affected by having a bad disk for some reason, then you'd see it as a spike, as long as you're tracking that kind of stuff as well, right? This stuff is since server start, all of these statistics, right? That's one thing to point out. Either since server start or since you truncated the underlying performance schema data as well, because you can truncate all of these tables too to reset all of the statistics if you want to. And not just if you want to, sometimes you'll need to as well, right? These are unsigned big ints, they're picoseconds. It can fill up, right? I mean, if your instance is up for long enough, then you actually sometimes hit the max of an unsigned big int. And in that case, you do have to truncate the tables. But so what you need to really be doing is reading these statistics over time and computing the deltas of those statistics, and then graphing that in some way if you want to try and detect that, or even computing some, you know, moving average value and adding some triggering Nagios or whatever it is that you want to against that.
So I do have a quick question on that then. So just, I guess, general heuristic, you know, is it good practice to, if you do have like a constant system that's collecting this data over time, to truncate on every collection maybe, or some common period, maybe daily? Like, is there any recommendation around there?
It's really up to you. So we collect all of the performance schema statement digest data in MEM, and we don't truncate every time we get it, but we do compute the deltas between the two. And it depends if you want to be lazy and just select, truncate, because then the diff is whatever you select, versus actually putting some time into selecting, figuring out how to compute the deltas properly, and leaving the statistics to be maintained over time. What we recommend, and what I recommend, as a tooling guy, is leaving the data alone and figuring out how to compute the deltas, because as a DBA or something like that, you might want to go in and do some of this, by hand, trying to figure out what's going on with the system over some period of time without relying on a tool, right? There might be some data that you want to look at in a slightly different way to the tool. And if you've got the raw data in the server and it's left and it's not truncated, then you can do that, right? Versus if some tool is truncating it from underneath you all of the time, then it might be a bit annoying from a command line perspective.
Yeah, and so another question I had, just real quick, was because I agree, you should probably just collect this over time, calculate the deltas on your own, and most monitoring systems will probably do this for you by, like, out of the box with some, maybe you flip a bit somewhere or something. But so periodically you do have to truncate this, or maybe you just restart your servers often enough that it gets truncated at that point. But if I were to issue a truncate statement on this in a replication topology, would that replicate down to downstream slaves as well? And is that something I should be aware of? Yeah.
No, any statements against a performance schema table, like a DML, against any of the setup tables, or any truncate statements against any of the tables is not logged in the binary log. It doesn't go downstream or anything like that. It's disabled from doing any of that. There was a bug at one point in an early 5.6 or 5.5 version where it did replicate. But that was a pre-GA version. So in any GA version out there, it doesn't.
Mark, the sys schema, as contrast, is only composed of views, right? There's no data in the sys schema.
There's one table that is persistent in sys, and that's this sysconfig table. That's actually an InnoDB table.
Okay.
Probably better if I do it like this.
Right. So if I deploy sys, do I then need to manually take sys?
You're breaking up for me. I didn't hear.
Yeah. Sorry. Yeah, I was asking if I am deploying the sys schema, do I need to manually take care not to replicate it, the sys schema itself?
If you don't want those things replicated downstream to recreate the sys schema, it's really up to you. I mean, the only thing that will affect any kind of data is the data in this table. Everything else is a simple view on top of the performance schema, or a set of functions and procedures, and there's a couple of triggers that are actually on this table as well that set the user that did things. But otherwise, it shouldn't hurt to replicate it downstream. It shouldn't hurt to replicate it downstream, because downstream should be as up to date as the master anyway, so all the views should be there, or the underlying table should be there, that kind of stuff. But if you want to turn it off, then you can turn it off. You can disable the binary log, load it if you want to, and then enable the binary log afterwards.
Yeah,
there are certain things that sys does where it specifically disables the binary logs for certain things. That's not related to loading.
Okay, cool.
That was 5.6, or some of the really good stuff, I think, in 5.6 without going into too much depth on weights and all of that kind of thing. I want to show you a couple of things on 5.7, if you don't mind, and then we can go on to other stuff.
Sounds good.
So, I didn't really show summaries, right, before. I should have shown that on 5.6. But the one thing with summaries is we break them down by the user, by the host, by account, by threads, and globally. So this is the statement summary global. Shows all of the statements on a global level, and then we break it down by user or thread or host. 5.7 adds this program as well, so we actually instrument stored programs in 5.7. You can actually debug things like procedures and what they're doing, and the underlying statements and how long they take, and all of that kind of stuff. It links together in the events between programs and statements. So you can get an overview of that. Transactions are actually taking up a level in 5.7. So there's transactions that link to statements, that link to stages, that link to actual wait events. So you can see the length of the transaction. Give you some actual real data there. So you can see the thread ID, who did it, the event IDs, the state of the transaction, its transaction ID information, if global transactions IDs are enabled and like, you get to see those kind of things. And then what kind of transaction it was, so whether it was a read-write one, its isolation levels, save points, that kind of stuff. But then the nesting data, so if you have a statement, it will link through to its transactions, and you can have even a set of statements and link all of the sets of statements to the transaction to get a good idea of all of the statements that were executed in a transaction, for example. That's one of the new things in 5.7. Then we have these, which are coming along in 5.7 as well. So where you had show global status and you had the information schema status tables, for example, and the variables tables, we're actually pulling those into performance schema as well now. And it's not just those ones, but we have these ones too, which are breaking it down again by the account, the host, the thread, the user. And to give an example of these, it's all of the status variables, but these are actually just the session status, not the global ones, right? The things that are affected by a user rather than all of the things that you see in show global status, like the background, InnoDB stats, and all of that kind of stuff. So we break it down on a per user basis. You can see exactly the amount of stuff that are affected on a per user or on a per host or thread basis. So you can actually link that through to who's connected now and get their individual statistics by connection ID, for example. So you can see exactly the statistics on a per thread connected basis. I think this is pretty cool stuff as well in 5.7. We have the metadata locks, so that's something that was added in 5.5 and was a bit of a black box. And now you can actually see, what metadata logs are actually in effect at the moment. You can see in this case there's only one, which is my statement has issued a table-based shared read. Has it granted against this table obviously, because it's actually selecting from that table at that point in time. So you can see exactly the types of metadata locks that are held open. That was really hard to debug before in 5.5. You couldn't figure out who was holding open metadata locks and that kind of stuff. Now it shows you exactly who has them, whether they're actually waiting or have the lock granted, so you can quickly debug who is holding metadata locks and who's waiting for them, and figure that out and kill the right sessions, for example.
Just completely out of curiosity, Mark, if I were to delete a record out of that table, would it actually kill whatever's responsible for that metadata lock?
No, you can't delete from, I mean, yeah, there's no DML from this one. So
Darn.
let's try it, hey. Yeah, there you go, you can't actually delete from that one. Then there's all of these memory summaries, so that's another thing that people have been asking us for a lot. Was, you know, there's no way to track what memory is actually happening in the server. So now we have this memory summary table. It looks like this, so it gives you the type of memory allocation, how many times it's been allocated and freed, how much it's allocated and freed over time, and then some high and low watermarks for those things and the current amount. I'll show the sys view for that because it's formatted in a slightly better way, but I can't even remember what it's called. So the big consumer is obviously my buffer pool, and on my little test box it's this 136 meg. I'm going to bring down this. Oh. That didn't work how I thought it would. But you can see how many times there's been allocations against it, the current amount allocated. So buffer pool, some internal memory usage for InnoDB, the log file buffers in this case, lock memory in InnoDB. Then these are the performance schema ring buffers that are there. So the history long table takes 13 meg, table handles take 9 meg, whatever it might be. And you can, yeah, you get a very accurate picture of exactly what is allocated, you know, really quickly from this kind of down to, you know, very detailed statistics about, you know, internal lock-free hash structures and all of that kind of stuff. It gives you, you know, exactly where all of the memory is being taken in the server based on an allocation type, essentially. So key cache there is actually the MyISAM key cache. This is InnoDB lock structures. This is table share structures. No, actually, this is table share structures. Hash tables in InnoDB. Transaction information, double write buffer information. You know, it gives you a very, very accurate picture of when memory is being spent.
How expensive is it to actually run the queries against these memory instruments in the performance schema? Because, like, I'm wondering, is it kind of on par with querying? I think it's like the InnoDB pages table. In
no, it's not like InnoDB buffer page.
Okay.
So InnoDB buffer page actually locks the buffer pool mutex and then pulls page information on a page-by-page basis and pushes it into a structure in memory when you're selecting from it.
Yeah, that was super expensive, I remember.
Yeah, it's crazy expensive, especially on large buffer pools. I mean, it locks the mutex for, like, it locks the mutex, reads 10,000 pages, unlocks the mutex to try and let somebody else do some stuff, and then locks it, you know, for the next 10,000 or whatever. What happens with this memory instrumentation is actually what we do instead is we wrap something like malloc, and that's how all of the instruments work in performance schema. They They don't do it based on when you query, which is how a whole bunch of this old stuff works in the server. They instead wrap the functions that get called, and they do the instrumentation in the wrapping. So where the server internally might have done a malloc, for instance, in a 5.6, it would in 5.7 call my malloc instead, or MySQL malloc, whatever it might be. And then the wrapping will, record how much is being allocated, and then call the malloc underneath the covers as part of the wrapping that it's doing, and then return back. So it's actually recording the instrumentation at the time that it's happening, rather than the time that you're actually selecting to try and get the data for it.
Okay, so this is actually really cheap to query then, once it's running.
Oh yeah, I mean you can see it here, right? Well, all this is doing is actually it's hitting a buffer in memory, because all of the performance schema tables essentially they have this buffer in memory for the instrumentation that gets pushed into it, and you're just selecting directly from the buffer in memory the current statistics rather than going and generating them at runtime. So it's really cheap, essentially. Yeah, so that was memory, showed all the session status and all of that kind of stuff. And then there's all of these replication tables. I don't actually have replication running, but it's taking the output of something like show slave status, but putting it into a normalized set of tables instead. So where before, when we started getting things like multi-threaded slaves and you wanting to actually interact with some of the data, programmatically in the server, you couldn't really do it because you couldn't do that with the show command. But now it's just properly structured tables in performance schema. So you can see on a worker ID, what its last status is and errors and those kind of things. You can actually get some statistics about it as well. Delays, retries. There's actually more statistics that we actually want to add in there. And then as we're getting things like multi-master as well, then you can see on a per connection basis. So you'd have one row per connection on a multi-master type system, what their status is. So this is connection stuff is like the I/O threads, and applier stuff is like the SQL threads in all of this. So you can see their configuration on a row-by-row basis, which is essentially multi-threaded slave or multi-master on the I/O side. So a proper result set rather than just a single output from show slave status, which doesn't make sense once you start getting into all of the multi-threaded slaves and that. So we've got all of those properly modeled in performance schema and exposing all the data. I wish I could show you something, but I don't have replication run at the moment for that.
So using these replication instruments, can you also get it data about like how fast replication is moving, or to like help you gauge if you have a replication problem, or what is causing replication to slow down potentially?
Well, one of the things with performance schema actually is that all of the replication threads are instrumented in performance schema as well. So you can see on a per thread basis all of the statement statistics, for example, for a specific replication thread in performance schema 2 if you wanted to. So that would probably be a better way of telling you why it's slowing down rather than it is slowing down. One of the things that we do plan on adding is a busy timer in the status by workers. So probably in something like this table, showing exactly how long those workers have been busy versus idle, so that you can get a picture of how busy the actual threads are. That's something that we've got planned. I'm not sure when it's going to go in, but it is something that we've talked a lot about. As well as things like lag and properly tracking lag, not based on some kind of
not based on applied timestamp in the replication log.
Timestamp across the replication stream, but actually times in queues and all of that kind of stuff. And different statistics across the different times in the different queues that happen internally in the server. So that's all planned work, and you'll start seeing that in these kind of tables, but broken down on a per thread basis.
That's honestly pretty awesome. So we've got about 5 minutes left if we want to start wrapping up, or if there's any other last-minute cool things you want to show off.
Is that not enough cool things that I showed off there?
No, Mark, you need to show us cooler things, like ASCII graphs and...
Yeah. I would like to point out Simon J. Mudd's PSTop tool. So PSTop is a top-like tool for performance schema. So PS is performance schema, and you get all these nice screens. You just run PSTop, and you get all these looks by table, IO by table, IO by file, like sorted, like what are the busiest tables, what are the busiest files, what are the busiest queries, etc. It's a great tool. You should find, you should look at it. It's on GitHub, so just Google for GitHub PSTop, and the first result leads you there.
Yeah, it's very cool.
Yeah, here's the GitHub link Shlomi was just talking about. This will be in the show notes.
Yeah, that's the one.
And it looks like I'm trying to load a blog post about it, but it's not coming up. So yeah, definitely check that out. Okay, yeah, so that'll be in the show notes. I'm actually just curious, Shlomi, have you used PSTop yet?
We're using it all the time at Booking, so it was developed by Simon at Booking, and we're using it all the time. It's pretty awesome. It really provides, it aggregates the data given by performance schema. It just shows you the main thing you're looking at, what's going on right now with my database, and I've used it a couple of times to figure out like a specific problem. Oh, sure, yeah, these tables are being the busiest, or the binary logs are right now the busiest, and it really makes sense. It puts order into a database.
Yeah, it does all that delta calculation that we were talking about earlier, right? It's just reading reading it on an interval, computing the deltas and showing you the deltas in the interval, and then sorts by the most busy, up to the top. It's really cool. Definitely try it out.
Yeah. Exactly. Yeah.
Okay. All right. Well, I mean, this is pretty awesome, just getting all this content and just kind of high-level information. And I think the ultimate takeaway is, if you're not on 5.6 yet, get there. Turn on performance schema. Once you've got performance schema on, definitely check out Mark's blog posts about it, and for things that you might want to turn on and off, that will kind of help get more visibility in the server. But it sounds like defaults in 5.6 are pretty good. And sys schema, performance schema is great. Get sys schema to really be able to leverage that stuff quickly, and definitely check out PSTop as well. Sounds like that's a pretty amazing tool for kind of keeping an eye on all this stuff.
Yep.
So, all right, thank you so much for your time today, Mark, for cracking open a terminal and just kind of doing this on the fly. And Shlomi, thanks for just kind of the interesting tidbits of information and questions here and there. And I guess that's a wrap. The next time we meet, so we actually won't be, I don't think we'll be live streaming the next time because it's the week of Percona, but we do have a room scheduled for a BOF for DB Hangops. I think it's on Tuesday night at Percona. I'll post more information about it on the blog, though. So if you're going to be at Percona Live in 2 weeks, definitely come find the DB Hangops group in person, and we can just kind of chat about all the stuff we normally do.
Jealous. Enjoy.
See you there, Jeff.
See you there, Shlomi. And Mark,
And who won't
if I can
be
get
there?
internet, maybe we can stream you in. Who knows? It'll probably be a really awkward time in the morning for you, though.
In the evening for me, actually.
Alrighty. Well, thanks very much, guys, and we'll see you all, if not in 2 weeks in person, we'll see you in a month for the next one, for sure.
Yeah.
Cool.
Later, guys.
Thanks. Bye-bye.
Take care.